g of x would be 2x minus 7. Okay? So that means then that f of 2x minus 7 would be 3 times the quantity 2x minus 7 to the negative first power. Agreed. So far. I don't like that negative 1, Rubes. I'm going to fix it. I like it much better now. Yeah. I told you I didn't like the negative 1.
But I thought you meant like you were putting it at the bottom, so I was like, what the heck?
So, do I like negative exponents? Heck no. We don't like them things. So that tells me that f of g of x is going to equal 3 over 2x minus 7. Yes, ma'am.
So I got the same thing like that, but I did it, I changed f of x in the beginning.
To 3 over x?
Yeah.
Oh, there. Okay. Now, let's talk domains. What is the domain of f of x? All real numbers, but x can't be 0. Because if x is 0, then we're dividing by 0, right? 0 to the negative 1 power is 1 over 0, and that's not going to happen. Okay? Let's talk g of x. No, just g. Just g, it's all real numbers, right? Because there's no fractions, and there's no even indexed radicals. So g just has an all real numbers. So now, domain of this pink box. All real numbers. And how do we come up with x cannot equal 7 halves? Set the 2x minus 7 equal to 0. Or really say it can't equal 0, right? And so then 2x can't equal 7, so x can't equal 7 halves, right? Okay, now, there used to be a game show on TV called the $64,000 question. The $64,000 question is, what is the domain of f of g of x? Or the domain of the overall thing? All real numbers. Oh, that was going to work. It's the orange one? But what about the blue one? What's the domain? Is that what you're going? Negative 7? Or you're switching?
No.
x can't equal 0 and x can't equal 7 halves? Why not the 0 one? I'm curious. So, because I can put 0, because we start this, to find f of g of x, we put something into g first, right? And then we put that into f, right? So if I put 0 into g, what tell me I got? -7? And I put -7 into f, I get -3/7, right? That works. So that 0 one I can kind of just forget about because of the order that I'm going in. I'm sorry, your what hurts? It's called logic. How to use it.
But the question is since for the ones that like g of x have that, we should always check for see if it comes to 0 or not before putting it in front of it.
She's saying that you should always check the restrictions first. And yes, you should always check the restrictions because that's what's going to determine if there's restrictions in your final answer. Okay? Yeah, buddy. Go for it. So, g of x is g of x, but let's focus in here on this f of g of x part. So f of g of x would be f of 2x plus 1. So that's going to be 3 times 2x plus 1 plus 2. So that's going to be 6x plus 3 plus 2, which is 6x plus 5. Agree with me on that? So, g of x divided by f of g of x is going to be 2x plus 1 over 6x plus 5. Right? Can I go any further? You want to go further because you see the 2 and the 6, right? And you want to reduce that to 1 over 3, right? But why stop there? Then you could just say x over x, well that reduces to 1. There's an x on top, there's an x on the bottom, they cancel each other out, right? So now you've got 3, or excuse me, you got 1 over 3 plus 5. Well, 3 plus 5 is 8, so why can't we go all the way to 1/8? Because that's not how math's done. Okay? If this were all multiplication, yes, you could reduce them all. Okay? But it's not. There's an addition sign on top, there's an addition sign on the bottom. So if I'm going to factor something out, it's got to come out of all of it. Come out of both parts. Okay? Now the last class, after we went through, we had about a 5-minute discussion about that, which was fine. It was a great discussion. Okay? Then they came up with the, well, so it's just like parentheses. Yep. It's just like parentheses. So if you need to write those parentheses around that to prevent you from just chopping stuff off, put those parentheses around that and stop chopping stuff off. Okay? With me? Now, let's look at the domains here. The domain of f is all real numbers, right? No fractions, no even index radicals. the domain of G by itself is all real numbers. No fractions, no even index radicals. If I look at the domain of f of g of x, that's all real numbers also. That's this blue line right here. Okay? If I look at the domain then of g of x divided by f of g of x, then that's going to be all real numbers, but now there's a fraction. So 6x plus 5 can't equal 0, so x cannot equal negative 5/6. Okay? Put those all together, we only got that one restriction, right? And so that one restriction happens where? Where does that one restriction happen? When the denominator, when what is equal to negative 5/6? Where is that restriction? When f is that, right? Okay. So if I put in negative 5/6 into g, what do I get out? No. No. I get out negative 2/3, right? So can I put in negative 5/6? Yeah. I can. No, it's not. Okay? So what do I have to look at? Let me erase this part right here. G can't equal what? No, well, so how'd you get negative 1/2?
I said g equals 0.
No, G can equal 0. Using your brains here in this one. What can't G equal? Nope, G can equal 0. If G is equal to 0, okay, or so if G is equal to 0, I put 0 in for F then, right? And I get out 2. G of x can't equal what? No. G of x can't equal negative 2/3. Right? Because what happens when G of x equals negative 2/3? F of x becomes 0, and I get what as a denominator? 0. Okay? So 2x plus 1 here can't equal negative 2/3. Right? Subtract 1. divide by 2. Now, you may be saying to yourself, we already had that. Okay? We did. We already had it. Okay? But now we've confirmed that x can't be negative 5, 6. And that's the only thing that it can't do. Okay? What we did there is we found what values of f make f 0. Or what values of x, I should say, after we plug it in, would make f 0 after we put it in to g. Because g is on the inside in the denominator, that's what we got to look for. That g of x part can't make f be 0. So g of x can't be negative 2/3, and it worked out this time. Okay? So, looking ahead to the next week and a day. Okay? Today, we did this. We're done with 6.3 now. Okay? This homework due tomorrow. Tomorrow, you need to have a charged Chromebook and some earbuds. Because we're going to do a little blended action thing tomorrow. Wednesday, we'll continue on with 6.4. Thursday, we'll finish up 6.4. Friday, there is no formative. Okay? Because you're actually going to take it as one of the stations tomorrow in the blended learning thing. Monday, we'll review 6.3 and 6.4. Tuesday, we're going to take, it's a little bit longer than a quiz, a little bit shorter than a test, so we'll call it a quest on Tuesday. Okay? And then Wednesday, Thursday, Friday of next week, we're off.